Hi all, welcome back to my channel. I've got a fun project I wanted to show. I've been working on it for a few days and I thought it would be great to show what I've managed to do. So this is a TTGO T-Display. It's a cool little piece of hardware. It's got a built-in screen and it's ESP32. It's also got USB-C, which is sometimes a bit of a mission to get the cable for, so sometimes I do choose other boards that still have an old USB connector, but it's kind of cool. And yeah, I wanted to show you a bunch of things. So the whole thing that kicked this off was actually a project that I saw by VolosR with the new TTGO analog readings, and this was actually kicked off by the new TTGO, which has a much bigger display. But I figured this one still got some legs in it, and I felt like doing a video about it. So there's a couple things I want to show. This repo is called ButtonMasher. And basically it's a simple little setup where you can see the display as well as all the different settings of all the different pins that it's bringing in. So if you check here, you can see all the pins, and if I touch any of the bits cables that I've got connected, you can see that they activate. There we go. So I've connected up all 7 touch pins as well as the 2 built-in buttons over here. You double click, it can go into a separate mode which shows a single one. So some of the things that I'm super excited about. Firstly, we have it's one of the first projects that I've written using Platform.io. Platform.io, for those of you who don't know, it's alternative to using the Arduino Studio. And one of the most amazing things about it is you actually define your environment. So with the Arduino IDE, you end up having to change settings every time you want to upload to a certain device. And actually with this, you can set for each project, you can set the platform, the board, you can set multiple boards and choose which one you want to upload to. And it also actually brings in all your libraries. So I've installed Wi-Fi Manager, which is another thing that I'd love to show. And I'm using Button 2, which is a common library for the button presses, and a BODMA TFT ESPI, which is pretty much a guaranteed necessity for anything that uses a screen. One of the cool things I can show while I'm inside here is this is the first time that I've managed to use this library without having to edit it. So for my Arduino IDE projects, I'd download the ESPI library, and then I'd have to go and modify the code to say which setup to use. And in here, inside this project, I've just set up the build flags, user setup loaded, and then thankfully there is actually one of the setup files for it, the setup 25, which is specifically for this display. And this automatically downloads all the latest versions, all the fixed versions of the libraries I want, and here's the setup for using this specific screen on this board. So some of the code, things I wanted to show. The Wi-Fi Manager is pretty awesome, so I can actually set up everything. So I don't set up passwords for Wi-Fi, and the SSIDs in here. I actually set that up inside of the Wi-Fi Manager. And other things of interest, button 2. So we've got the LCD that we initialize at the start. And then the other thing that you can see on the screen is that we have the, let's just pop that more to the side. We've got an NTP time server for no real good reason other than it's fun to have. And yeah, so the other thing I wanted to show is if I open up my web browser, you can see here, in addition to having this repo here, I've actually got index.html, and this is being served up by an interesting website that I found that's called raw.githack.com. And I can have this show a HTML page, and this HTML page actually has a WebSerial installer for my device. So I'm going to connect up to that now. Excuse my Linux, and let's just connect up. So it should connect up without issues. And one of the cool things is I can actually upload an image here. So anyone can go to this website and install this version of the software for this ESP32, which I thought was actually amazing. So you don't have to download firmware blobs and applications. You can literally actually flash this from this website. So I will do that in a minute and then show you the libraries. So this is the logs that are coming through. Every frame, it actually logs the different settings, so you can see whether the pins are enabled or not. There's 3 pins at the end, and if I grab the other set of 4, so basically the 4 pins from the one side and 3 from the other, you'll see the values that it's bringing through. So let's go back, I'll connect again. With the touch buttons, I found it a little bit finicky to find values that work. And so what I want to show is that I've actually set up just a simple struct to hold the buttons. It holds all the values that it needs for the graphs that you've seen. Let's actually make this bigger. No, it refuses. No, don't freeze on me. For some reason, this has stopped taking my input. Hey, live demos. Okay, let's quit and we'll just load it again. Okay, so inside of here, we've got the NTP server that it connects to. Gonna keep going down. Oh, Platform IO loading up. Thank you, Platform IO. Where is the interesting code? So I've split it up into the digitally reading the pin, which actually just takes the button to state and puts it in there, and I fake some analog values, so I just treat these all the same. And then the touch read pin also touch reads the pin, and then it just saves a bunch of values, so I keep the average for the pins, as well as keeping the last 24 values on each struct. When we start up, that is just now, here is a double click for changing the mode. So if you double click either of the buttons, it'll move through all the pins that are set up in here. This is a button to handler for when you're pressing the button, when you release the button. And then for the touch pins, I actually build up the thresholds in here. So all the pins are treated, all the buttons are treated the exact same. Just have a flag to say whether they're digital or not. And because I'm generating analog readings regardless, I can just run through them. And once I've built up 24 averages, so don't touch any pins when you're starting it up. When I've built up the 24 averages, I take that average and I take a value 3/4 of it and I turn that into the threshold for the touch pin. So ideally, every time you restart it and you aren't touching the pins, it'll form a threshold value that's 3/4 of untouched, which seems to be a good value. You'll notice that you'll see the little pin blinking whenever I touch it, and if I touch it really quickly, you can see that I can actually get some pretty good touch values coming through there. The setup, we go through each of these. Button 0 is actually just an aggregate storer, as well as temporary values for when I shift the values down in the array. I've assigned different colors to each of them, and we have the digital pins. And then we go through the TFT ESPI setup, where we set up the screen, and then we auto connect to the Wi-Fi, which is actually a good point to maybe kick off the firmware. So when you install the firmware, it's going to erase everything, including any stored data on the device. So let's do that. And you'll see it kicks it off, and hopefully in a few seconds we'll see that it's erasing the flash, and then it's going to start writing the flash in a moment. There we go. So let's bring that off to the side there. See, I got this set up right, so we can see that it's busy installing there, and I can keep going through the code. So this is the auto connect library I've used, and at startup it's either going to auto connect to whatever's saved to the device, or it's going to set up a access point where we can go and configure it, and we'll do that in a moment. After that, it'll build up the thresholds, and then it'll start the 2 pins that we've got. And then you might have noticed when the code is running, it draws little blocks that show, draws points on line to set everything up. Here we go. This is starting up now. I'll switch to that in a second. So on every loop, we're just checking if the Wi-Fi is connected. We can get the time, and it's just configuration the first time we start up. Work out the FPS which is on the screen. We loop through the buttons, so every frame we'll loop through the buttons. And we'll print the local time from the NTP server. That's just a cool little thing to have on there. Then we go through each of the buttons, and as I mentioned, you'll see that depending on whether the button was set up as digital or not, we'll either do the digital read or the touch read. And the thresholds are only set up at the start, but that seems to work fine for me. Who knows, in the wild that might be different. Okay, and then the rest of this is just actually setting up the display. I think that might be easier to see if I actually have the code running again. So I'm going to switch to the access point that was started up. So we just wait a moment, it should pop up here. We'll switch to the ESP32 and then a chip ID. And I'm going to wait for the Auto Connect Wi-Fi portal to pop up. Anytime now. We shouldn't need this anymore. So here's the hotspot, which is quite cool. And we can configure the Wi-Fi from here. So if I click Configure Wi-Fi, it's going to take us to the Wi-Fi screen, and I will set it up to connect to the same Wi-Fi that I was using a moment ago. I'm glad I'm not live streaming this, which I was thinking of doing, because that would have messed up with this quite a bit. Okay, so there we go. Don't look at my password. And save. We should get kicked off the Wi-Fi, and then we'll go back onto the proper internet one, which is the same one that I've connected it to. And there we go. Screen just popped up. Camera's come back. I hadn't realized that knocked off because I was off the Wi-Fi. And so let's just zoom in a bit there. And so now you can see I've actually gone and uploaded an old version of the firmware. So that will be a good segue in a second to actually show you updating that firmware. So you've seen the Wi-Fi, setting that up is actually pretty straightforward and easy. And we're going to go on to the new version of the firmware in a moment. So some of the other things, it does draw the grid, and it draws all these different blocks, and it's got rounded corners. It's very, very cool. You'll notice all of these scales because I took this code from VolosR, and he'd set it up for a different screen with a different resolution. I actually found it easier just to have a macro that was going to do the conversions for me initially. I've tweaked some of them since then, and I got back to something that I could work with. I should really go through and actually calculate all the values, but yeah, it's a small project for now. I can tell you about some of my plans later, and we'll see if we get to them. Depending on whether you're showing one pin or all of them, it's set up over here. And this is just setting up the grid to make it look nice, and then going through the 10 buttons and drawing their graphs. So if it's got a color defined and it's pressed, then it'll draw a rectangle in a certain place on the screen, which you can see all those rectangles set up now at the moment. So each of those indicates that a button's being pressed. And if we carry on, there's some things to show the battery. So this is not the battery pin on this, unfortunately. And the mod was old code to show random values. Initially, I just actually built a sprite, which I scaled to the screen. That was quite slow. I immediately regretted that. That can go away. And then, so once we've set up the sprite, at the end of the scene, we push the sprite to the screen, and that's all done. And then from the values you've been seeing, this is just printing to the serial port. On a previous project, I found this could slow things down quite a lot. So you might not actually want to do that all all the time. It should just maybe be a debug mode flag, which I've done in the past. So when we go through our build process, I'm actually going to build now. And you'll see that it makes sure I've got all the right libraries local, compiles the C++ file, builds the firmware. I hope I didn't set this to install. Perfect. So I just built the firmware. And if we go into the build folder, I should ESP32 dev. Then we'll see the firmware bin that's been created. I'm going to open this in the containing folder. I'll copy this out, and inside my project folder I have a firmware folder, and this version of the firmware is the one that I want on the website, so I'm going to copy that there. It did take a bit of working out. The app 0 as well as the DIO40M, these are pretty standard, and then the partition layout I've been using the default, which is I think a 1.2 meg firmware with the ability to auto upload. So you have two 1.2 meg spaces on the SPIFs on the ROM, and you can actually upload over the internet to update it. I'm not using that at the moment, and then the remainder is used for the SPIFs that allows us to actually store files on here. And one of the files being stored will be the Wi-Fi setup. Okay, so now that I've done that, I can get back to my console. If I go get status, you'll see that I've been busy on this, so I'm just going to add everything. We'll commit that. Update to, and this is enabling us to have dynamic thresholds on touch. Okay. Oops. As is the case of all live demos, I had to just quickly change something. So I've now added my Git account to this PC. So just to show how awesome having Platform IO is, I basically installed it on this laptop, downloaded the project, and the first time I built it, it installed all the tools I needed and everything I needed. And that's not good. Okay, and we are going to push this up now, hopefully without issues. I should have maybe done this off screen. Come on. Yay! Okay. So if I check my Git status now, I have a clean branch locally and my firmware should be uploaded. And if I go to check this on the other web browser window I had, here we go. Then I can reload and I should see the updated firmware 37 seconds ago, updated to include dynamic thresholds on analog buttons. Okay, we'll switch back, and I think it is time now. We'll install the new version of the firmware. I think there is actually a setting where I can tell it not to reset, which is quite cool. A little bit zoomed out. There we go. So we'll leave it like this for the rest of this one. It's just installing the firmware. Well, I suppose I can show you installing. So this will be the latest version now. And like I mentioned, raw.githack is actually really cool. Obviously there's hundreds of thousands of ways you can serve this. You can even put it on a normal branch, but you basically just put your URL in here and it'll give you a GitHack URL that you can use on your pages. So this was really simple and easy, and I liked it. Okay, once ButtonMasher is installed, I'll just set up the Wi-Fi again. Yay! Okay. And Should be done in a minute. There we go, installation complete. I've got my new setup, and let's reset and see what it's doing. So Portal's running, that's good, waiting on clients. And this is where I will switch here. So switch the Wi-Fi networks. And lose my screen. Okay, I'm just going to configure the Wi-Fi. So you can see here what's happening on the actual device itself. Choose the Wi-Fi, input the password, save, and then we can see we're up and running. So let's switch back to the other Wi-Fi network. Should get my camera back, and there's the device up and running again. And that is about everything I wanted to show you on this. So I said I'd mention some future plans for this. I am pretty excited to maybe hook up a small little board, and that would allow me to actually implement buttons. You saw how reactive the button presses are, so now that I've got the dynamic thresholds back in there, you can see little press, so we could actually get pretty good twitch timing on this for pretty much any games we wanted to play, and yeah, looking forward to that. So if you enjoyed this project, I'm going to try upload a few more in this vein, maybe once I've got like a proto board with the pins hooked up on it. Actually, let me show you. So at the moment I've just got pretty much a standard pin there, and you'll notice that with the light touch they get detected pretty quickly. And then just to show on this, you can see there and there. And just to move through the screen, you see every time I double click it shows you the pin number, and so we can just view a specific screen instead of all of them. It still shows all the buttons and the clicks, but yeah, it's a fun project. So I'm hoping to build a small game console out of this, and for any game that I put on, we could easily have a screen on the index, so it could actually build up a repository of games. Let's see, ButtonMasher. So the same way we've got the SkidTag screen with the firmware, could actually build up a small repository of games that you can actually flash directly from your web browser, and just by buying one of these ESP TTGO T-Displays and a USB cable and Chrome web browser. So Edge and Chrome are apparently the only ones that support WebSerial at the moment, but I have used this on Linux and Windows and macOS successfully in Chrome, so you can actually flash from any operating system, which is really fun. So I think, yeah, WebSerial is something pretty freaking awesome, and I think everyone should take a look at it. Was there anything interesting in the code? Like I mentioned, I did have a bit of trouble with getting the setup initially, but just grab everything except the firmware bin. You would make your own firmware bin, and then you'd be able to include that. And in the index file, the library that it pulls, it's just a single HTML file, and there is an include in here. So here's the package. I'm just pulling the package from unpackage.com. It's ESP Web Tools install button. And once that's installed, then you can give a few things: your repository, your name of it. I've left the link to ESP Web Tools, which is where you can get all the code for theirs. And then there's a manifest file that needs to match up to your name of your button. There we go. So this is literally called button. Okay, I should have been more original. And then you'll see here there's a file called manifest button, and in this it actually specifies all the different parts. I did actually struggle with the offsets as well when I originally did this, but it's all set up here. So if you're going to go with the stock standard firmware, let's just check if I specified anything about it. I don't think I actually specified anything about the firmware. So yeah, it's pretty much defaults. You could grab this project, start writing your own code, or move a project you have over to Platform.io, and then once you've got your firmware, upload it into the same spot, build your manifest file and your HTML file to point at your repos, and you're good to go. So I hope you enjoyed watching this. Yeah, and if you liked it, please do like and subscribe, and I'll try get up a game at some point in the near future, which will be available to download via a very, very similar mechanism. Thanks for watching. Bye.